Welcome to the channel. Sinusoidal signal is applied at the inverting terminal of the operational amplifier, and we have to find out the nature of output waveform for the given circuit. So I'm dividing this circuit into three sections. First one is inverting amplifier. Since the input is applied at the inverting terminal of the op-amp, whereas positive is connected to the ground, feedback resistance is of 10K, the output voltage, and this is input voltage. Inverting amplifier, non-inverting amplifier, I explained in previous videos. I'm providing the link in the description box. If the input at inverting terminal of the operational amplifier gain is negative, means output is out of phase as compared to input. Second operational amplifier, which is given in open loop configuration, and this is nothing but the comparator. Here the input is applied at positive terminal and the negative terminal is at ground, which means that this is the reference voltage. So the output voltage in this case will be plus V saturation if input voltage is greater than V reference voltage. In this case, the reference voltage is 0 since the inverting terminal is connected to ground. The output voltage will be minus V saturation if the input voltage is less than V reference, which means that if the input is at positive terminal, which means that if you are applying sinusoidal signal at the inverting terminal, what we are getting? Square wave output. If input is above 0, then we are getting positive output. If below, we are getting negative output, and this is V saturation. The saturation voltage we are getting because of open loop configuration of the operational amplifier, gain will be high. And in the other case, like if positive terminal is connected to ground and input will be at inverting terminal, so we are getting the output is out of phase as compared to input, since the input at inverting terminal. And the exact opposite condition, that is we are getting output voltage negative if V saturation is greater than V reference, or positive saturation if V input is less than V reference, since the input is at negative terminal. But in this case, the input is applied at positive terminal, so we are getting positive V saturation if input voltage is greater than V reference, and output voltage will be minus V saturation if input voltage is less than V reference voltage. And third condition, which is given in the circuit of the N MOSFET. So in this case, it's NPN type MOSFET, which means that if the input voltage is positive, MOSFET will operate in the saturation region. The operation regions of the MOSFET I explained in previous videos. Again, I am providing the link in the description box to check the different regions of the MOSFETs. So if input voltage is positive, MOSFET will be in the saturation region and will be acting as a closed switch. So these are the three main conditions to solve this type of circuit. Coming to the solution of this circuit, this is inverting amplifier, means input is positive, output will be negative. So initially output will be 0 or negative. What happened at the comparator? The comparator output will be negative, and if input is negative, MOSFET will be in cutoff region, MOSFET will be off. So simply this amplifier acts as a inverting amplifier. So in the first condition, we are getting gain will be minus 10K divided by 1K into input voltage. So for the positive half cycle, the nature of the output will be like this. Because of this negative sign, for positive half cycle, output will be negative. The second condition, what happens during negative half cycle of the input? So during negative half cycle of the input, the output will goes above positive reference line. So if this positive terminal voltage above the reference line, so output goes above the reference line, which means that some positive voltage will be there at a non-inverting terminal of the operational amplifier. So in the comparator, as I explained, if the positive voltage is greater than the reference voltage, the output will be plus V saturation, and output will be high. MOSFET will be in the saturation region. So in this case, we are getting two resistances in parallel because MOSFET will be in the saturation region. So 5K resistance will come in the picture, and we need to take the parallel combination of 5K resistance and 10K resistance in the feedback. So now gain will be changing here. That is, after taking the parallel combination of 5K and 10K, what I'm getting 50 divided by 15. So after solving, we are getting this one. So this is the resistance in the feedback. Calculate the gain using this resistance. The second condition, now calculate the gain. So this is the parallel combination of the resistance 10 by 3K divided by this 1K. So in the second case, the gain will be negative 10 divided by 3. Since this is 10 by 3K divided by 1K, and after solving, what we are getting minus 10 divided by 3 into input voltage, which is equal to output voltage. So I explained this case. When the input is negative half cycle, output goes above the positive reference line. If output goes above the positive reference line, positive voltage will be here. The output of this comparator will be maximum, I mean to say positive, plus V saturation. MOSFET will go into the saturation region. So we need to take the parallel combination of these two resistances. So we are getting 10 by 3K resistance. So this resistance divided by the input resistance with negative sign. This will be the gain of the inverting amplifier in the second case. So as we observe that in the first case, the gain is maximum 10. In the second case, the gain is divided by 3. So we are getting positive voltage but with less gain. So during negative half cycle at the output, we are getting maximum gain, and during positive half cycle, we are getting the minimum gain. And this is the nature of output waveform of this circuit. Thank you.